Great. Welcome to Project Astoria, building great Windows apps from your Android code. I'm John Justice, the Director of Program Management for Project Astoria. With me is Rajesh Sundaram, Director of Engineering for Project Astoria. Today we're going to talk about what Project Astoria is and show you how you can take advantage of it to bring your applications to Windows Mobile. Now, I just found out that this is starting at the exact same time as the NFL draft. So if any of you follow American football, I am impressed with your dedication that you're here. If anything exciting happens, please feel free to shout. All right, before we get started, at the end of this, we'll have this QR code up. This is the link to our session evaluation. We'll put it up at the end, but if you have comments for us, please do send them along, especially if you liked the talk. We do take that stuff pretty seriously. Great. As you saw in the keynotes, Windows 10 represents a significant opportunity for you as developers. It's going to help you build engaging and diverse experiences, scaling from mobile to holograms. You'll be able to reach over 1 billion users on a variety of devices around the world through universal Windows apps. But while universal Windows apps will have the best reach and the deepest integration with Windows, many of you have code on other places that you'd like to move to Windows. Now, of course, if you already have universal apps, you are in the best position possible to take advantage of the universal Windows platform. If you have Win32 or .NET apps, we welcome them. You're also ahead of the game. If you have code from the web, you can directly target Project Spartan, or use Apache Cordova, or our hosted web apps to seamlessly stay up to date with your website, but get native access to the universal Windows platform. If you have apps based on middleware like Xamarin or Unity, we welcome those too. And finally, if you have apps from other mobile platforms, including both iOS and Android, we welcome them as well. Windows provides bridges for you as developers to bring your code from all of these platforms to Windows. In just a minute, we're going to dive into building a Windows Astoria app. But first, let's take a minute to talk about Project Astoria and Project Islandwood side by side. First, both projects are free SDKs that will be available later this year. Project Islandwood that lets you use your Objective-C code from your iOS applications. Development is in Visual Studio. You get good code reuse, and you get full integration with the universal Windows platform. Astoria brings both Java and native Android code to the Windows platform. With Astoria, you use your existing IDE. We support Eclipse, IntelliJ, and Android Studio. With Astoria, many apps will work with zero or very little modification. All right, let's dive a bit more into Project Astoria. OK. Let's switch over to the phone there. Dave Treadwell showed you a preview of a Project Astoria demo app called Timber. Now we're going to dive a bit deeper. So Timber, with a B, is a sample app that we're going to put up on GitHub as open source, so you can check it out yourself. It's an app that'll help you find the national park that's right for you. All right, so let's start on an Android phone, since this app was originally built for Android. I can like parks or pass by swiping left or right. OK, I don't like that one. Too many trees. All right, that one looks good. It's nice and snowy. OK, we're going to take a look at where this park is by clicking on the location icon. Now, when Rajesh clicked on that, that called into the Google location service. Of course, if I were on Windows, I would expect this to use the Windows location service. OK, now, I do like that park, so let's click into it a little bit. Now, I want to share this with some folks. Great. So when we click on Share here, this is the Android Share intent that pulls up the Android Share menu. If I were on Windows, of course, I'd want Windows Share contracts. OK. Now, the app also uses Google Maps to locate the park. In the Windows apps, of course, I would want Bing Maps. If I wanted to add a comment on the park, Timber would use the Android keyboard. Of course, on Windows, I'd want the excellent Windows keyboard with its excellent Windows emoji. Now, let's switch over to a Windows phone. OK, this is Timber, repackaged as a Windows app. The app uses 100% of the Android code that you just saw running on that Android phone. But we aren't just reusing the code. We're delivering the user experience, performance, and security that Windows users expect. Users have told us time and again that they love the Windows Phone design, and they expect apps to fit into the Windows Phone experience. Now, in Windows, I'm going to select a park that I like. All right, let's see how far away that one is by clicking on location. Now, location just works, calling into the Windows location service. Let's go over to share. Now, when we share, this is bringing up the Windows Share menu without any code change. OK. Now, let's go over to the maps. You can see that these maps, these are Bing maps that are being added in. Again, we'll show you in a minute exactly how to make this change. Now, let's add a comment. And again, just like I hope, the Windows keyboard came up. What is it, the fastest keyboard in the world, I think, right now? OK. But now I want to do something that the Android app isn't able to do. We're going to go in, and this app uses live tiles. So we wrote a few lines of code to do this. We'll show you how in a minute. But let's go and take a look, and we can see that Timber is a live tile. Now, to get apps like Timber, users will get them from the Windows Store, just like any other Windows app. We'll show you this in just a minute. All right. But first, let's go and build an app. You and other developers have told us over and over that you want to reuse your code, use your familiar IDE, and keep your existing workflow and tools. So in this demo, we're going to show you how to create a Windows app using your Android code, reuse it, or using your familiar IDE and your current development machine. We'll do some live debugging, we'll integrate with Windows services, and we'll integrate with Windows features, all with very little effort. Now, Rajesh is going to take us through this.
The very first step is to find out what changes I have to make to the app. So I'm at the Project Astoria app analysis page, which is part of the Windows Development Center. I'm going to click on this link and upload the APK of the original Android app. This web page performs a static analysis of the APK. It identifies all the Google Play services that are used by the app. We also take a stab at converting all the Android icons into Windows-style assets. And you developers have a choice of using the icons converted by the web page or replacing them with your own assets. These were the icons that service converted. I'm now going to drill in on Google Play services to see what the web page found. The web page correctly identified that this app is using 3 Google Play services: Google Location, Google Maps, and Google Cloud Messaging. We are now going to show you how to convert this app into a Windows app with no code change. To make that possible, we wrote a service interop library. This service interop library automatically converts all the Google calls to Microsoft equivalents. In this example, the Google Location service is converted to Windows Location service. Google Maps is converted to Bing Maps, and Google Cloud Notifications, Google Cloud Messaging is mapped to Windows Notifications. The next step is to click on this link and download the SDK, the Project Astoria SDK. This is a one-time operation, but to save some time, we have already done this on this demo machine. I'm now going to switch to IntelliJ. The Project Astoria SDK comes with a tool that automatically converts your Gradle file to allow you to build flavors for both Windows and Android. So you developers do not have to fork your code. It also automatically adds a dependency to Microsoft services. So the Windows version of your app can use the Microsoft services instead of Google services. This tool is purely optional. You're welcome to do this step by hand. I'm now going to compile the app. While the app is compiling, I'm going to use a tool called WConnect. This tool also is part of the SDK. And the tool WConnect takes an IP address and connects to the Windows emulator that's running on this machine. In this demo, we're going to show you the emulator, but we also support debugging and deploying to real devices, both via USB and Wi-Fi. So this tool connects the Windows emulator to Android Debug Bridge, also known as ADB. We support all the ADB commands that you may be familiar with. I'm going to give you 3 examples. ADB devices, which lists all the connected devices. As you can see, the emulator showed up as a valid device. ADB shell ls, which lists the directory listing on the emulator. And finally, ADB logcat, which allows you to see the logs generated by your application. I'm going to switch back to IntelliJ, and the emulator now shows up as a valid deployment target. So I'm going to click OK and deploy the app to the emulator. While this is happening, I want to explain what is happening under the covers. We take the APK and convert that into a Windows AppX. This allows us to run the app as a native Windows app in a trusted and secure environment. The app asks me for my location, and I'm going to click yes. I click on the location icon, and this location information is now provided by Microsoft Windows Location Service. I'm going to click on this Spark, and this map comes from Bing Map. I'm not going to show you everything here, but whatever you saw in the consumer demo will just work. I'm going to navigate back to the main page and show you live debugging. So I'm going to like this Spark. Right here, we have set a breakpoint in the trigger write function, and we support your identical debugging workflow. You can set breakpoints, you can step into code, you can step over code, you can watch variables, really the whole thing. Now that I have shown you how to convert your Android code into a basic Windows app with no code change, it is time to add a few lines of code to take advantage of some of the features that are uniquely available only on Windows. So we're going to show you 2 things. We're going to add some code for live tiles, and then we're going to show you how to map from Google Cloud Messaging to Windows notifications. So I'm going to switch to the Windows tile updater.java file. And the first thing I'm going to do is add a bunch of imports. And then I'm going to scroll down to the update tile function and add just a few lines of code for live tiles. I'm just going to scroll so that you can see what I've typed here, just a few lines of code. This is the exact same Windows Live Tile API. What we have done is we have made that API accessible to you in Java via projections. Now I'm going to compile and deploy the app to the emulator. So while this is happening, I want to speak a little bit about what happens in the real world. In the real world, your app server will send a notification to a cloud messaging service, which will then redirect that onto the device. In this demo, we are going to simulate that using Fiddler. We have also made it really easy for you to change your app server code, because your app server code has to take care of both Android apps and Windows apps. So it's literally a one-line URL change on the app server code to route the message to a Windows device based on a Windows prefix. So this app is now deployed on the phone, on the emulator. So I'm actually going to pin the app back to start so that you can see the live tile. Oops. And I'm going to copy the registration ID from logcat here. And as you can see, this starts with the keyword Microsoft. This is the queue to the app server that this registration ID comes from a Microsoft device, and for them to use the right URL to send it back to the Microsoft device. So I'm going to copy this URL. And I'm going to paste this in Fiddler. Now, using Fiddler, we are sending an HTTP request. This is the same HTTP request that your app server would send to the cloud. I'm going to bring the app here. So the very first thing that I'm going to do is send a toast notification. And there you go, you got that toast. And this happened without any code change because we automatically mapped Google Cloud messaging to Windows notifications. I'm now going to make a one-word change to send you send a tile update. I changed this word toast to a tile. And if you pay attention to the tile, you're going to see that flip. I'm going to try it once more. It flipped, but it flipped back very quickly. Well, the tile was supposed to flip. This code is still in development, so.
As we just proved, this is actually a live demo using real connectivity.
Before this demo, we tried this 10 out of 10 times, and it worked every single time. So now that we have built, I've shown you how to build a Windows app using your Android code. I'm going to walk you through the store ingestion process.
Flipped? Yeah! There you go.
11 out of 11. So the Windows, this is the same developer Windows Dev Center that you would use for all your Windows apps, regardless of where it came from. So you use this page to manage your Win32 apps, Project Islandwood apps, and everything else. I'm going to click on this link and upload the APK that we just built. Now to save you some time, I'm going to show you how the page is going to look after the upload process is finished. As you can see, there are a bunch of greens here. And now now you're ready to hit submit. And as soon as you hit submit here, the app is now going to be available on the Windows Store after the store ingestion process concludes. So that sort of concludes the store ingestion process. But wait, there's more. We know that many of you use a Mac as your primary development machine. And we have thought about you as well. The entire workflow that I showed you here also runs on a Mac. So I'm just going to switch to a Mac machine and show you that. So that's IntelliJ, and this is the Windows emulator running on a Mac. So that concludes the developer experience demo. Back to you, John.
OK. All right.
Okay.
And then the networking gods were playing with us for a little while, but they came through in the end. OK, what we just saw, we took some Android code, we reused it to build a great Windows app with the Windows UI, including keyboard and Windows sharing contract. We showed how to debug it. We showed how to enrich it with a live tile. We also demonstrated just how easy it is to use the Project Astoria interop library to redirect your Google service calls to Microsoft services with just a simple configuration change and no code. And finally, we showed you using the Windows Developer Portal, both to analyze your app and determine recommended changes, and then manage the onboarding of your app. OK, so how did this actually work? As you can imagine, there's some pretty significant differences in architecture and design between Windows and Android as platforms. So to save you as developers a ton of time, we've done a lot of work translating these concepts and translating these concepts, doing the heavy lifting for you, remapping the key user experiences, cloud services, and platform APIs. So we're going to dig into each of these. There we go. Let's start with user experience. When someone uses a Project Astoria app, they expect the experience to be the same as any other Windows app. So Windows ensures that touch, input, interaction, windowing, notification, and other aspects of the experience all work well. Windows apps built with Project Astoria will be available for download from the Windows Store, along with any other Windows apps. Users don't generally pay a lot of attention to what tech powers an app, as long as the app delivers the right experience, performance, quality, and security. So this is how Timber would show up in the store if I were to submit that, and if we pulled up its project page. It's going to download like any other app. Once it's downloaded, it's available for immediate use. We don't have to do anything special here. OK. So we're windowizing all of the most important experiences for apps built with Project Astoria. We recreated controls, interactions, and experiences to match the Windows UX and to eliminate any clashes of interface concepts. So even though I'm just showing one example, this mapping of experiences and concepts is the same thing we do all over the system. for UI concepts, API mappings, or kernel-level syscalls. So here's one example we're going to dig into, copy and paste. So in Windows, customers expect copy and paste to work like it does everywhere else on Windows. So this is how an app built with Project Astoria looks. When you select text, it looks like just like you'd expect. That's different from how it looks on Android. On Android, it looks like this. Similarly, the copy button is directly above. On Android, it floats at the top as a menu. It looks pretty different and a little bit jarring. We didn't want those things, so we replaced them for you automatically. Now, if I go to paste, paste as well on Windows, I use the keyboard that use the paste button that's always available on the keyboard. On Android, I have a separate paste button. It looks pretty different. So we've removed all these jarring differences. OK. All right. Click. There we go. All right. Next up, let's talk about services. Windows apps built with Project Astoria, they need to light up engaging user experiences while generating revenue for you as developers. You use a number of cloud services to do this, and we're providing a rich SDK for Microsoft services in Java to meet your needs. So you can create revenue ad opportunities with Microsoft Ads and Analytics. You can support freemium and other popular models with in-app purchase. Powerful services like Xbox Live, Windows Notification, Bing Maps, Locations, all of these enable you to create engaging experiences. On the platform side, when your app uses low-level or core platform capabilities, including graphics, files, sensors, et cetera, Windows takes care of mapping those out too. Now, some of this technically isn't about mapping APIs, just one call to another, but fundamental platform concepts like lifecycle, when apps are suspended, when they're killed, et cetera. What apps are, or what processes are allowed to run in the background, or resource attribution and management, so that Windows knows exactly what's executing using system resources. If your app uses sensors, other local hardware, local files, or other resources like contacts, Project Astoria redirects you to the right Windows experience. So good performance and long battery life are critical to a good user experience. We get both of these from two key pieces of tech. First, we run these apps in the universal Windows platform container, applying the same resource management policies that we apply everywhere else. This is important for performance and battery life, but also for security, which we'll talk about next. The second key piece is the platform remapping itself. What's important about this is how we do it. Our subsystem does not run a second OS. We're not running a second kernel. Instead, we've done the harder work of redirecting each of the low-level calls you need directly to the Windows kernel. This low-level mapping significantly improves efficiency through close integration with the rest of Windows. Now let's switch to how the Universal Platform Sandbox and other investments are make sure your users will be confident that all apps that come from the Windows Store, regardless of the code base they're built on, are safe. So our security model is designed to protect the user in multiple ways against multiple points of threat. First, on the platform side, we've built the system and the architecture with security in mind, reducing the chance of malware taking advantage of vulnerabilities in the system. So what does this look like? Well, first, we start with the Universal Windows Platform Sandbox. We build this on top of any base security that we get in the Android subsystem. Running in the Universal Windows Platform Sandbox results in tighter control over app behavior and system resource access. This cuts down on the attack surface area, reducing possible threats compared to Android. For example, several common malware attacks on Android use SMS as a means to attack the user or the device. On Windows, we tightly control the SMS interface, so only trusted apps can run. Next up is security through the store. We have a sophisticated store ingestion process that screens developers and apps to ensure that good apps from good developers with a good history are available in the Windows Store. Now, I'm sure that everyone in this room writes great apps that are highly trustworthy, but for the people outside the room who write things that might not be, we want to make sure that we have good screening. Finally, monitoring and rapid response. With users' permission, our monitoring services look at anonymous device telemetry, and we look for how we can detect malicious behavior from apps. Users have a direct channel to Microsoft to report malicious or suspicious behavior in any apps, And then we have a team of security researchers who's monitoring our devices and the Android ecosystem to identify the latest threats and vulnerabilities. We'll provide rapid updates to the system and through the store. We'll act quickly on user reports and address potential threats. Okay. All right. Let's recap. So we just saw how Windows 10 provides a bridge to bring your Android code to Windows. We'll be releasing this SDK for free later this year. We're welcoming your Android code. We support your IDE on your dev machine. We support integration into Windows, including live tiles, and all of this ends up in the Windows Store. Now, thanks for coming today. If you'd like to learn more, I encourage you to stop by our booth, test drive the SDK in a hands-on quick start challenge. If you'd like to help us shape the technology or just follow along, sign up for updates on our website. We'll link you to Channel 9 videos, blog posts, and samples over the coming days. Also, if you have any questions, we saved a good amount of time for Q&A here at the end, and then we'll be at the Windows Insiders Lounge for the next chunk of time to answer anything more. All right. So if you have questions, please come up to the microphones and ask, and we'll try to answer everything you got. Yeah, Rajesh, if you come back up, that'd be great. Great. Go ahead. Thanks.
So I had a few questions. My first is we use a lot of low-level socket programming APIs in our C++ code.
Sure.
Will you support like multicast and broadcast and all that stuff?
Let me tell you about the general way that we go through supporting all this stuff. What we do is when we start working with folks, say the folks in our TAP program or more now that we're talking about this, we go and do static analysis over all of the apps. So that compatibility wizard is based on, we have an engine that can go and find out what are all of the calls that you make, all the local calls, all the remote calls, all of those things. And then we go look across all of those APIs, and we say, okay, which ones, we do cluster analysis, say which are the ones that cluster together, what's the most valuable, and we prioritize in that way. So I can tell you that we will have the most useful calls in that area. I can't tell you if we have one particular one or another, but if you send me a mail, I can let you know for the particular thing. Or if you want to make sure we have coverage for it, stop by our booth, we'll scan your app, and we'll make sure we have the right stuff.
Cool. Okay, and I had two really other quick questions.
Yeah.
If for like background services, do you just kind of ignore those, I'm assuming, because you can't have...
No, actually, we're building support for background services. In the code that we're demoing today, we don't have it to show. It doesn't work yet, but we're working on building it in right now. There's some real differences in the way that we handle background services and the way that Android handles background services, but we've got a mapping there that we can do.
Cool.
And it's very much our intention to leave the user in control. So we want to provide a trustworthy, like battery-efficient background implementation.
Right,
Yeah, that's the trick there with background services. On Android, it's pretty much open season, so you can do anything with background services and just drain the battery to nothing. We're trying to make sure that doesn't happen.
Okay, cool. And then lastly, do volume keys work? Could I get those, or is that still kind of not allowed?
Volume keys.
Yeah.
You mean Android
like
licensing keys?
The hardware volume keys. Like, can I get the key events for those?
The key that's for this, to unencrypt the Android subsystem?
No, I mean volume keys. Like if the user uses the volume keys and you want to override those.
Yeah.
Sorry.
Yeah.
Now I understand. I thought you were asking a licensing question.
no,
You're talking about hardware support.
Yeah, sorry.
Totally.
Yeah.
Yes. We should be able to support volume keys. We remap those just like back button and all the rest of the kind of stuff. So we'll go inject those into the right APIs.
Cool. Thank you.
Yeah. Sure thing. Let's switch over to the next one over here, and we'll just alternate back and forth.
Sure. So my question is around theming and like the system controls and things like that. One is how much do you transfer? Two is like how much more can we do to try to make it fit within the Windows OS? And three is what are the store requirements around if we don't theme it?
Yeah, okay. So let's start with, you saw some of the stuff we showed here already. We showed remapping some of the system dialogues. We remapped into all the kind of a system callable UI. We're taking care of those one after another to try to make sure that those are all feel like Windows. And we can't go in and change the app itself, the way that the app looks internally when it's not calling into making system calls. So that's really up to the developer. We don't currently have any any policies that require you to make significant changes there. We'll be setting those as we get a little bit closer and further on. I can tell you that we're trying wherever we can to make it just feel natural. Now, there's a bunch of stuff that, to be clear, if you want to take advantage of things like adaptive UI that will help you scale your app across different screen sizes and things like that, that just doesn't exist on Android. That's something that you can only get by going and doing something universal from the start. So if you want to go target HoloLens and Xbox and desktop and mobile and all of those things, you have to go there. You could try to code all of that stuff manually, but I think it's a better path just to start with the UW, Universal Windows App. Cool.
So
All
what if I already have a Xamarin Android application that we want to use here? Because the development team knows C#, they did it shared code with iOS, and there's no management effort to target a Windows view. So can we use our Xamarin IPKs?
Well, I would take your Xamarin code and just use it to target Windows directly instead of
Well, the problem is that
APK
management has no interest in creating the view level components for that. So we have the views done in Android using the Android widgets and the Android services, and we get the IPK out and they say, look, can we just drop this into Windows Phone now?
To tell you the truth, I haven't tried it. I don't know if that works today. Do you know, done an evaluation? All right, we can check it out. I would expect most people who are doing Xamarin development just to target Windows because it's pretty straightforward.
Stop by our booth, and if you don't mind, drop your APK, and we can take a look.
Yeah, let's check it out. Okay, next over here.
Yeah, hi. A couple of questions. Will you support the system-level APIs that typically require system signing, like privileged APIs?
In general, we're supporting privileged API access a little bit different across the two different platforms. Most apps that we've worked with so far haven't needed them, so we don't have those in the system now, except those that are called by our own subsystem components. If there's something that you need in particular, again, come by and we'll take a look at your thing and see what you need.
Okay, it's more like device administration type stuff.
Yeah, some of those scenarios are going to work, and some of them just won't. That's when you get into the limitations of things like system utilities. System utilities, a lot of those, they just won't work in this world. You've really got to write those just for the single OS that you're targeted.
Thanks.
They're lower level than anything else we do.
Kind of assume so.
Yeah.
How about the differences in the security models between the platforms, like being able to share files between applications, or the differences in the Bluetooth APIs? How do you handle that?
Well, those are different things. If you talk about, so for security itself, we do that wrapper. We put everything within the Universal Windows platform runtime, or sandbox. And so we get that kind of protection that goes around. When you're doing sharing between apps, say you're doing an intent and passing something over there, we'll remap the individual intents and pass those over so you still have a way of accessing those. Just like we showed you in the share contract, you can do similar kinds of things to do.
But what about like shared files and differences in the Bluetooth APIs where you have, probably more access on Android but less security? So platforms have made different decisions.
In general, when there are differences in security, like there are some places where Android will let you do interception of basically the whole HTTP stack, which is just a fundamentally insecure thing to allow. We just don't allow it.
Okay.
We're defaulting to let's protect everybody. Let's lock it to
So you kind of default to the Windows state, which is more secure.
That's right.
Yeah.
That's right.
Okay, thanks.
Yeah, we're not going to compromise security to bring on any apps.
Thanks.
You want to take from here, John? These people are waiting.
Oh yeah, please.
He was going to ask me.
Oh, middle.
Yeah,
I didn't even see middle. Sorry.
Does it work only on Windows Mobile or also on desktop, tablet, and so on?
So it's on mobile today. That's what we've been focusing on. These are apps that are typically written for mobile. So mobile and tablets that are running mobile will support all of those.
Okay, another question. Do you support also video player support for Android TV, Android Gear, and something like that, or it's out of scope?
So some of those certainly we don't today. There are new APIs like casting and things like that we've looked at, and there's very little uptake of them yet. And so we look and we don't see a major need for that. Instead, we've been focusing on ones that the apps that we see are using a lot more.
And normal video player works, or?
Well, video play is one of the interesting ones because you want to go intercept the video and then move it to our hardware accelerated path. I don't actually know if it's in the build that we have right now. Josh, do you know?
No.
Because there are
I know
a lot-
it's in development. I know that work isn't completely done. We may have something that we could show now, but the way we handle that is intercept the request to play, and then we pass it on to our video subsystem.
But for all of these scenarios, we're going to pick the most optimal path to deliver the end user experience. And if the optimal path requires us to switch over to Windows and use the native Windows stack, we're going to do that.
Right.
Okay.
And that's
thank
what we
you.
do all the way throughout here. We go and take that intercept and then pass on to our subsystem to go do the work. Cool. Go ahead.
Hi, just a couple of questions. One, does it support secondary tiles?
Secondary tiles.
Yes.
Saying
Okay.
yes.
Easy.
I think that's actually hot off the presses that yes, it
Yeah.
does. But
Access to contacts, so the address book, creating a custom contact store and that sort of thing.
contacts we do support. When you go down the list of local objects, we support most local object access. There are a few things that we still have to add, but contacts is already on there.
Okay, thank you.
Cool. Let's go back over there.
Yeah, two quick questions. First one is, what Android API level did you target when you were making your menu of things?
Sure. So looking out first we looked out in the wild, and we're somewhat shocked by the number of API levels that are out there.
Hence the question.
So everyone we worked with right now is targeting fairly old API levels. So we support KitKat, and so supporting KitKat is actually a lot newer than what almost anybody is targeting today. There are almost no apps that are targeting Lollipop natively today or requiring Lollipop. So supporting KitKat should see us for a while.
Awesome. And the other quick question was, in a session yesterday on application lifecycle in Windows, we learned about these new brokered sockets that the application can get suspended and wake on socket data reception.
Yep.
Will that be an allowable wake method for these hybrid apps too?
I don't know. I'd have to follow up on that.
So we showed you an example of live tile via projection. And eventually, we can add other support for other native Windows APIs via projection as well. So eventually, our goal is to cover more of the native Windows API surface via projections.
Thanks.
Great. Let's switch back over to this.
My Android application is targeted to several versions of Android, and because these versions provide different AP, and I have several wrappers inside to hide different SDKs. So my application runtime checks the Android version to select the proper wrapper inside. So how this problem is proposed to be handled in your project?
So you should, first at build time, you'll be able to detect that you're building for our platform. So if you have to do anything in particular, you can go make those updates. But beyond that, we'll also report back to you the API level, just like you would you'd access in your code today. And so you can take a look at that and see, and then make any runtime choices that you have to make. Does that answer your question?
I'm not sure.
All right, try again. Let's make sure we got it.
Okay, if my application checks and it checks the Android version in runtime, so
Yes.
which version will be reported?
We'll return KitKat.
Okay, see. Thank you.
Yep. Great.
Hi. For the interop library that you guys have for Google Play Services, Google has since has versions of that are broken out into much smaller components. Do you support that same broken out structure?
Broken out structure. So, can you
So
say more about
specifically
it?
like maps, if you only want the maps component of Google Play Services, you can add that into there without adding, another 20,000 methods, which, approaches the text limit.
We are working on that.
Okay.
Today, we just showed you the simple one-line mapping, but we're going to work on that scenario as well.
Okay, thanks.
Yeah, today's had everything in a single jar that when intercepted. Cool. Let's go back over there.
Okay. So, again, about Google Play Services, are you supporting the activity detection portions of that as well?
Do we have it in now? Yes, they're saying yes.
Okay. Thanks.
All right. Oh, yeah, go ahead.
I got a quick question regarding the audio services. Like, do you provide background audio and all the audio APIs that there is on Android?
So background audio, that's one of the background services that we're working on adding. We don't have that yet, but that's mostly because just those differences between the background execution models. When we have that in, background audio, I believe, will be one of the first background services that we support.
Okay, and regarding all the other APIs, like if I want to do foreground audio, there are lots of, like the media extractor or audio tracks, all those classes that are in Android, are those already supported in Project Astoria?
We're going to have to look at individual ones. Typically, if something is popular, we're a lot more likely to have the support in already, and then we'll just add things as people need. So I can't answer for a particular one there. We'd have to go scan your thing, take a look, because there are just tons and tons of possible methods there. So we can scan it, take a look, and see if we have support for it.
Okay, thanks.
But come by our booth, and we'll take a look.
So I have an app which has native code as well as a web view controller. So and we kind of like switch back and forth between the two. So how does that scenario play out?
That works just fine. We support native code, we support Java code, we support web views embedded, all those things together. So that's very common app pattern, so we had to support that.
So does the web view get converted to a Windows web view controller?
So the web view controller today does not.
Yeah.
It's one of the things that we're looking at. We'd really like to. The Edge engine is pretty cool. So we want to get on that, but we're not there today.
You know, again, our approach there is we want to take, for each of these scenarios, we're going to take the most optimal path that delivers the best end user experience without compromising the scenario.
All right, thank you.
A very specific question you might not be able to answer. On Windows Phone, you can only sample audio at 48 kilohertz, but on Android devices, you can sample at lots of different sample rates. And I have an app that samples at 22 kilohertz. I'm just wondering, will that code just work on Windows Phone?
You were right. Let's see. Do we have the audio person?
You know, we have not looked at that scenario, but you know, but like he said earlier, we're going to look at the cluster map, and if that scenario is important, then sure, we will support it.
Sure. Just one other
the best way to again is stop at the booth and give us your APK.
Definitely. One other quick question. If you have a native iOS app and a native Android app, and you want to use these porting technologies to make a Windows Phone app, which is the best one to use?
Oh, I think they each have different approaches, so you've got to weigh it. If you've got both of those things, well, first, clearly, if you have Windows code, go with the Windows code. It'll be the best on the platform. You can take it the broadest places. You can do the most stuff. It's clearly the best thing to do. And with driving all of the upgrades and all that, it'll be a huge opportunity. If you've got just iOS and Android code, if you look at it, and one of the questions you should ask yourself, is one of them my lead code base? Do I lead with one of these? Do I do the development on this one first and then port over to this one? If so, that's gonna push you one direction or another. The next thing would be, you'd say, okay, I'm willing to do some work. On the Project Islandwood side, running against iOS code, there you have to do a little bit more work in Visual Studio. But in exchange for that, you get full access to the platform. You get to call into the whole Universal Windows platform, which is valuable. So on the Astoria side, you don't typically have to do as much work. It's usually very little overhead, but you don't have as much integration available into the system. So that's the trade-off that you have.
Cool. Thank you.
Cool.
Okay. I have one question for the native code support.
Yes.
So if a game for such kind of applications, say use native NDK to develop Android applications, and then say use OpenGL, something like that.
Yep.
So do you support this kind of applications?
We do. Now, let's talk about games in particular. So games, we support OpenGL. We support OpenGL with a high frame rate. We go and map that over using Angle. Now, on games, a lot of games, more and more, are being built on middleware. If you're built on something like Unity, Unity has great native support for Windows already. Your best path there is going to be just using Unity and going and adding a Windows build target. That's very straightforward to do. So if you have that kind of middleware that makes that easier, go on that path. If you don't have that kind of middleware, then this is something you should check out.
And another question related is that because for Android, there is different kind of hardware API. For example, ARM, x86, so also maybe NVIDIA's as a hardware spec. So is there any requirement on the APK upload to check?
So sorry, are you asking about Android on x86, or are you asking about like neon optimizations, or what kinds of things?
Yeah, what I mean is that when I compile Android application with native code, I can choose the hardware settings, like choose compile to for ARM, or choose it to compile to be compatible with Intel x86.
Yep.
So it will be different APKs.
Yes.
So when I upload the APKs to be tracked with your solution,
yes.
So which hardware spec?
So
which hardware spec will you expect?
Well, today the most important one to move up is ARM. ARM is the platform that we have, almost all mobile devices are on. But we actually want to encourage and make it really easy to go submit both. We want to pull both of those flavors up there to make them available in the future.
Okay.
Today we support ARM devices, so you should start with your ARM version of the APK. But going forward, we plan to support more hardware platforms.
Okay. Thank you.
Let's do these as the last three, and then we'll head on over to the Insiders Lounge to answer anything more.
What's your approach for Android widgets, and do you have in mind to maybe convert that into Windows tiles at some point, or is this outside the scope?
We haven't done anything there yet. We're focusing more inside traditional apps.
Okay, thanks.
Hi. Android supports different layout folders, so you could target different screen sizes, different densities, different locales, etc.
Yep.
Does that just work on Windows Phone?
So what we're trying to do is handle things like you can query on resolution in Android and then set your layout based on that. We handle those queries by returning back the values, of course, from those Windows APIs, so we can drive the same transitions. Similarly, you have things like on rotation, you'd go, it'll tear down your UI and rebuild for your new orientation. That's the same kind of, we pass over the same thing. We didn't move around the devices during the demo here, but we do that same stuff. So our goal is to make that seamless. We just go through and fix any bugs as we hit them.
Okay, so I get it from the code's perspective or your query, but what about just layout folders? Like I have a landscape layout and a portrait layout. Does that just work?
I believe that we do handle both of those because those are pulled into runtime checks behind the scenes, and then we handle those runtime checks. And so all of the stuff that we've done there has worked so far, and I believe it'll just work.
Okay, thank you.
How about the Bluetooth stack support?
Yep.
Will you support both Bluetooth and BLE?
So this is something that we don't have a bunch of low-level support there for Bluetooth yet. If it's something that people really want, we'll prioritize it.
Okay.
And add it on there. I mean, this is early. The first time we talked about this is yesterday, so this is fresh, and we're going to be we're here to take feedback.
Okay. What about the scenario where you'd want to upgrade the app to a native universal app from an Android app?
Right.
Is there any migration strategy?
Well, you're going to be able to just replace the app in the store with something that's there. Now, beyond that, we're looking into some tools. What can we do to kind of make that easy? Because we really want everyone to go build apps that are deeply differentiated. We want to use all the skills that people already have that can tie into the platform. We also want you to be able to reach the broadest number of devices. So we want to make that path as easy as we possibly can. We don't have any tools in place today. You'd have to go and do the work, create the new version, but then it is straightforward to replace it in the store.
So this is definitely a long-term strategy, not just a stopgap solution to get an app in the store.
I think I'd still say pretty clearly our primary strategy. You probably heard a lot about universal Windows apps in the last 2 days.
That's what the question stemmed from. Like, if we wanted to write a Windows app, but want to get an app in sooner, and we already have an Android app, this seems like an attractive.
Yeah, it's a great way to put your toe in the water when you want to do the best experience and the broadest uptake. Of course, you should go native.
Okay.
Cool. Thanks very much. Come meet us in the Windows Insiders Lounge if you have more questions.